down 7, 8, 7, right, up 8. So you see that that same shape here. This graph does have an x squared in it, so it ends up being that same U-shaped graph, which I can't get all the way down to where the vertex is because this graph cuts off, but that's okay, because really I just need the x and y intercepts, which I have. The x intercepts are here at -1, 0, and 7, 0, or sorry, 6, 0, -1, 0, and 6, 0, and then your y-intercept is here at 0, -6. So I already kind of had set up, remember the second number in the x-intercept is always 0, so that's already kind of typed that in. Again, those x-intercepts are -1, 0, and 6, 0. And then the y-intercept is 0, -6. That's where it crosses the y-axis. So there's that one. Let's go to the next one. So domain and range, the way we're going to define domain and range is we're going to look at a graph and see if it goes on forever or not. And then if it goes on forever, we're going to say it goes from like -infinity to +infinity. If it doesn't go on forever, then we'll actually identify some numbers where it starts and stops. So this one right here, I already answered it, but I'll just chime in again on what it means. It's a parabola again, and the lowest point on the parabola, the absolute lowest value is -3 on the, that's on the y values. It goes as low as -3, but then it goes up forever. For the x values, this graph will continue to move up and left, so it will continue forever moving up and left, meaning it'll keep going to infinity upwards, as well as it'll go to -infinity as it moves left, because these numbers here are negative. So as the graph moves left, it'll move towards -infinity on the x-axis, and also on the right side it'll keep going to the right and up, so it'll move toward +infinity on the x. So anyhow, from left to right, it'll keep moving to opening up to further to the left and further to the right. So for x, for the domain, it'll go from -infinity to infinity. You can call that the domain, because any number will work for the domain. However, this graph for the range for the y will never get lower than -3. However, on the positive side, it'll always keep going up. It'll keep rising to infinity. So this graph will go from -3 to infinity in the range that is on the y-axis. So you see here, the range is that y equals -3 to infinity. There's different ways to write this, but I don't have too many options here in Desmos, so I'm just going to use words and numbers. On this one right here, I identified the domain and range as, remember, domain is x, so it goes from, in the domain, it goes from -6, right, from here, should use the line tool, to here. This is your domain, this is your x, it goes from there to there. And then on your y values, right, I should stretch this out a little bit, because you could see it goes from -6, goes from -6 to right here, which is 2. Well, you got to be careful with your intervals here. Each space is 0.5, 0.5, 1, 1.52, 2.53. So it goes all the way to 3 and all the way to -6. So that's what you have here, that x is greater than or equal to -6, but x is also less than or equal to 3. And then on the range is the y value. So for the range, it goes from here, which is -4, to here, which is 2. So the range goes from -4 to 2, which is what I'm saying here, that y can be greater than or equal to -4, or less than or equal to 2. I wrote it a couple different ways. I said the range is from -4 to 2, or aka y is greater than or equal to -4, and y is less than or equal to 2. Did the same thing with the domain, so there's that. Next topic, relative maximum and minimum. If you know the words maximum and minimum, then these will be pretty straightforward. A maximum would be found at the highest point, relatively speaking, and then a lowest point, right? Because this graph goes on forever. It looks like it goes on forever up and forever down over here. However, relatively speaking, this would be a high point, a max, and this would be a low point, a minimum. A maximum is like the top of a mountain, and a minimum is like the bottom of a valley. So you can kind of use these lines again to identify where your maxes and mins are. Right, if I go here through the, well, that should be straight. If I go from the max there and go down, you can identify the maximum as a coordinate pair. I mean, you might say the max is at, let's see, these are 5, 10, 15, 20, 25. These are 5 each, these spaces. 30, the max is definitely below 30. However, you can also identify it as an ordered pair where you also identify the x value. And these are 1, 2, 3, 4, 5. These are 1 space each. So 1, 2, 3. You could see the max is past 3. So that's why I put that it's negative 3.3. And it's a little below 30. So I put 28. The minimum here, down here, if you draw a line, use the line tool from the minimum, remember that's like the bottom of the valley, from the minimum to the y-axis, and then from the minimum to the x-axis. Actually, the minimum does go straight through 2, but it's definitely a little less than 40, so that's why I put 2 and negative 42. So that's my minimum there. Remember, maximum and minimum. Maximum is a high point, the top of a mountain, and minimum is like a low point, like the bottom of a valley. So if you wanted to show, you could definitely show this one the same as the last one, where you kind of use lines. Whoops, I should have used the line tool. You could kind of use lines to see where your max and min hits the x and y axis. That way it'll be easier. So look, it's 2, 4, 6, 8, 10. These are 2 each, so the max is just over 12, and on the y-axis, but the x-coordinate of the max it's over here. These are 0.5 each again, 0.5, 1, 1.5, 2, or negative 2, negative 2.5, and 3, negative 3 that is. So it's a little bit past negative 2, so you could call it, I don't know, maybe negative 2 point, or sorry, a little past negative 2.5, so I called it negative 2.75. I'm thinking that's a little off now, but I'll just let it be. It's close enough. And then up to 12.5. Well, it's a little past 12, and each of these is 2 units. So estimating this at 12.5 seems reasonable. The minimum, let's see. Let's draw some lines here to kind of check on that a little bit. That minimum actually looks really close to that right there, really close to 1.5 and on the x. And it does look below 20, so maybe negative 20, negative 21, or negative 20.5, something like that. So let's see here, that's 1 point, I'm going to just call that 1.5 over here. And then here, negative 20. You could call it negative 21, but it doesn't. It looks like a little bit higher than that. But if you're within range here, if you're close, these kind of make sense to be close because we do have to estimate a little bit. Next here, maxes and mins again. So you can see I did start doing this, and I have a maximum, of course, up here. And I've identified that as negative 3, 10.5, so that would be from here, or sorry, let's take a look at this, or sorry, negative 0.3 and 10.5, because remember each of these is 0.5 on this one, so I called this negative 0.3 and then up to a little past 10, 10.5, and then over here, I'm going to call this, I don't know, it's past negative 3.5, so negative 3.6 or negative 3.7, something like that, something close to that, and then all the way down to a little lower than negative 10, so the minimum here minimum again, I'm going to say is, I don't know, negative 3.7, somewhere around there at least. You got to be close. Should make sense. And then down to negative 10 point. I don't know. It's hard to estimate. I'm just going to say negative 10.5. Next, we're talking about increasing and decreasing. So when we identify the parts of a function that are increasing and decreasing, we describe the parts as intervals of the x-axis. We normally do use the x-axis. So for example, on the third function, this one down here, we could say that it's decreasing, going down from negative 4 to 2. So let's do a couple of these. I already started marking this one, and I marked in blue where it's increasing. You always got to look at a graph from left to right. So as this graph moves up, it's increasing. That's from negative infinity to negative 3. And then once you get to this maximum here, we don't need to worry about the maximum right now, but once you get to this max, it starts going down. It's decreasing here. It's going down, decreases all the way to there. So it's decreasing from negative 3 to 1. Remember, we always use the x-axis values to identify where it's doing what. And then the graph, once it hits this minimum, it climbs back up. So it's increasing from 1 to infinity. So increasing from negative infinity to negative 3, and from 1 to infinity. Decreasing from negative 3 to 1. This next one is, again, same thing, increasing and decreasing. So I'm going to go ahead and use the drawing tool here and identify that first of all. So remember, you always look at a graph from left to right. So from left to right, this graph is falling, aka decreasing. I think I have the wrong tool here. Let me switch that up. So it's falling, aka decreasing, all the way till it gets to that minimum. So it's decreasing, let's say from negative infinity. Let's just assume it goes forever up and left. So it's decreasing, going down from negative infinity to negative 4, and then it starts. Well, let me go back so I don't have to change colors again. And then over here, once it reaches this max, it starts decreasing again. So I'm going to use this, I'm going to use this same color to show it's decreasing in these spots. And the spot that I haven't highlighted, that's where it's increasing. So once it hits this minimum here, it starts to rise up. And remember, rising up is increasing. It increases all the way to that point, hits that max, and then back to decreasing. So you can identify that in words or with some numbers. So I went ahead and answered in words where it's decreasing. It's decreasing from infinity. Remember, infinity is that way on the x-axis, left. It's decreasing from infinity all the way to negative 4. That's what I say here. And then it's also decreasing again from negative 1 to infinity. This is negative 1 right here, negative 1. So from negative 1 to infinity, whoops, didn't mean to do that. It's decreasing again. And by the way, even though it's going down, it's still moving to the right. And to the right, we approach infinity on the x-axis. So again, decreasing from negative 1 to infinity. And then it's only increasing in this one spot. It's increasing from here, from negative 4 to negative 1. So that's what I say there. So we're now going to try and identify all 4 of these things: the intercepts, x and y that is, the domain and range, any maxes and mins, and where it's increasing and decreasing. So I'm going to call that 4 things. So let's just start with at the beginning. The x-intercept is, well, here's 1, and that's 1, 0, and here's the other one. That's 5, 0. So 1, 0, and 5, 0. The y-intercept is here at 0, negative 5. You should double check my points, but either way, that's where they're at. And then I have